Hi guys, welcome to geometry. So it's not quite time to start yet. It's pretty early in the morning, but I'm excited. I'm a little bit nervous, and sometimes when I'm a little bit nervous, it's good to exercise. So I thought I would go for a run. Would you guys join me? I think maybe we might find a little bit of geometry along the way. So before I even start, I'm noticing it must have been really windy last night because there's all these leaves here. But I think I'm going to start with a couple of them right here before we even start. Because I noticed all these leaves here, but I noticed this one here, it's right on the intersection of two line segments. So I'm going to call this leaf a point. A point names a location. Okay, so this point, I'm going to call it point L. Okay, so that's point L for leaf, of course. So that right there is point L. All right, I'm seeing a few other things. Before we get started, I see this cursive letter A, and then these three leaves with letters by them. So those must be points. So I guess we are going on a run, but let's figure out what this is. Okay, so basically, if you look, sometimes you'll see a plane. This is what we're going to call a plane. Usually you'll see just like a parallelogram or rectangle or square drawn, but technically a plane is a flat surface that extends forever in all directions. So this plane that you see how there are outlines here, like a square or rectangle, technically it extends forever in all directions. So it keeps going forever out that way and that way and that way and that way. Okay, so even though you'll see it with boundaries, it really has no boundaries. Okay, so we're gonna name this plane. Okay, and the way you name a plane is you can either name it with the cursive letter, or, so we can call this plane A, or you can pick 2 points that are not on the same line. And we'll talk about that word later, but that when they're not on the same line, they're non-collinear. So if you have 3 points that are not on the same line, like RUN, you can pick those. So we can either call this plane A or plane RUN, or any other order of those letters. So plane A or plane RUN. All right, so let's get going. All right, let's go. Let's see what we can find. All right, I'm just gonna look around and see what geometry I can find. All right, as I'm running here, I'm seeing lots of lines and segments and planes. We're just gonna keep going here. Okay, so I came across this deck and thought I'd just hop up here because I'm noticing a lot of like lines and segments and stuff. So I'm just gonna talk through this. So for instance, if I look at like this little post, okay, it ends, right? So if I look closely at this little post here, this post goes from A to B, from point A to point B. And point A and point B, those are called endpoints, okay, which makes sense because it's like points that are at the end of the segment. Okay, so that's what a segment is. Okay, a segment is like a line piece between 2 points. Okay, and to name that, you use the two letters of the 2 points. Okay, and so I'm going to call this segment A, B. This dog doesn't like that I'm writing on my deck. But you just put a little bar above the AB. And that's segment AB. Okay, so this is just what I was looking for. Okay, if you look here, this line, it extends both directions. Okay, so a line is a straight path that extends both directions, forever, both directions. Okay, so I'm just going to draw on this road. Okay, so since this line extends forever both directions, you just pick any 2 points on the line. Okay, so I picked points A and B, and you can call that line AB. And when you write line AB, make sure you put arrows both directions. Okay, I better get out of the way. Okay, now here's something else I was looking for. This line stops in one spot, but it goes forever the other direction. Okay, so you start with your endpoint, which is X. Okay, this is called a ray. Okay, so this is called ray X, Y. You pick any other point on the ray. Okay, and so this is ray X, Y. And you make an arrow going to the right, always to the right. You start with the endpoint and make an arrow above pointing to the right. All right, so on this line AB, I didn't even notice this point C. And we just talked about rays. So basically this A, this is called a common endpoint. So if you start with A, it goes forever this direction. If you start with A, it goes forever this direction. Okay, and I'm gonna move out of the way because I'm in the way of someone who's driving. But these are opposite rays. They're called opposite rays, AB and AC. And even though one goes to the left and one goes to the right, you always make your arrow to the right, and you always start with the endpoint.
Hi, so we're going to talk a little bit more about segments, and specifically something called the segment addition postulate. Okay, and that sounds complicated, but it's really not at all. Okay, so the segment addition postulate says that if you have this segment, and this whole segment is segment AC, but if we take the length of AB plus the length of BC, it is going to add up to the length of AC. Okay, and that's kind of just common sense. But notice here that there is not a bar above these, and when you don't put a bar above, that just means you're talking about the length. You're talking about a number instead of the actual segment itself. Okay, so we're just going to pretend, let's say that we know that this whole segment's length is 12. Okay, and then I am going to say that this piece is 8 and this piece is 2x. So what we need to do is we need to come up with an equation to solve to find x. So I am going to say that this small part, 2x, that's my AB, plus the BC, which is 8, and the sum of that is the length of AC, which is 12. And then I'm just going to solve. Okay? You guys all know how to solve because you loved algebra. And we get x is equal to 2. Okay? So therefore, x is 2, so then 2 times x, that means our AB is 4, and 4 plus 8 is 12, so we did that right. That's easy. Okay, and then the other parts that we're going to do right here, we're going to look at this one right here. Okay, and this one we've got the length of DF. Okay, we don't know the whole length of DF. That's one of the things we're going to find. We want to find the length of DE and EF, and these little marks here show that they are equal. Okay, so E is technically the midpoint of segment DF. Okay, so if it's the midpoint, if they're the same, we might as well just set them equal to each other, right? I'm just going to put a little equal sign there. Okay, and then I'm going to solve again. I'm going to get rid of my x's on this side. So I get 4 is equal to x minus 1. I'm going to add 1 to both sides. Okay, so I get 5 is equal to equals 5, okay, I kind of ran out of space, but if x equals 5, I'm going to plug 5 back into here, the 2x plus 4. So 5 times 2 is 10, plus 4 is 14. So DE is 14. Okay, EF, I'm going to take 3 times 5, which is 15 minus 1, 14. And then DF would be the whole thing, so 14 plus 14, or 28. And there we have it. So now we're going to talk about the angle addition postulate, which is very similar to the segment addition postulate, but with angles. Angle addition postulate says that if we have this angle ABC, and we have D somewhere in between, the measure of angle ABD, and we put this little letter N in front of it, the measure of angle ABD plus the measure of angle DBC equals the measure of the whole angle. So the small angle plus the small angle equals the larger angle. Okay, and I'm just going to make something up. I'm going to say that this whole angle ABC is 80 degrees. And I'm going to say that this angle DBC is 44 degrees. And then also I'm going to say that this one is 2x plus 4 degrees. Okay, so my small angle ABD, or my 2x plus 4, plus my small angle DBC, so plus my 44, equals the measure of angle ABC, which is 80. Okay, and then I'm going to use my algebra skills. Okay, I'm going to combine my terms, so 2x plus 48 equals 80, and then I'm going to subtract my 48, and I get 2x is equal to 32, and then divide by 2, so x is equal to 16. Okay, and then if I plug this in just to check to make sure that I'm right, if I plug in my 16 here, 2 times 16 is 32, and 32 plus 4 is 36, and 36 plus 44 does equal 88, or excuse me, does equal 80. So we did it right. Yay. But wait! What if it's set up like this? And we see these two little arcs here. This means that these two angles are congruent. This means that this ray EO is the angle bisector, so these are equal to each other. Okay? So, yes, that's right. We can just set these equal to each other. So we can go 3x minus 10 is equal to 2x plus 5. And then we just solve using our awesome algebra skills. Okay, so I'm just going to move the x's to one side. So I have x minus 10 equals 5. I'm going to add 10. So x equals 15. So if x equals 15, then I'm just going to plug 15 into my x in both of these places. Okay, so the measure of angle GEO would be 3 times 15, which is 45 minus 10, which is 35 degrees. The measure of this angle OEM would be 2 times 15 plus 5, which is 35, okay? Which is a good test to make sure we did things right, okay? And then the measure of the entire angle GEM is 35 plus 35, or 73. And we did it. Easy, right?
Oh, look. I even found some angles in my classroom. Imagine that. We've got a right angle and a straight angle. Two angles that together form a right angle are complementary angles, and two angles that together form a straight angle are supplementary angles. So you can do the same kind of thing with complementary and supplementary angles, except when you add the angles together, you need to set them equal to 90. Okay, and then you can work it out, find your x, plug them back into the expressions,
And for supplementary, it's similar, except you are going to, sorry about the glare from the light. You are going to set them equal to 180. So you take the two expressions, 3x plus 20 plus 2x plus 10, and set it equal to 180. Solve, we get x is equal to 30, plug them in, and you get 110 and 70. And you can check your answer because 110 plus 70 does, in fact, equal 180. So there we go. Fun stuff.
But what if I want to find, like, the distance between two of these points? Like, the distance between U and R. And I don't have, like a tape measure or anything. I wonder how I could do that. Like, if I knew the location of each of these points. Find the distance. But I could find, like, what point's in the middle, too. Wonder how that would work.
So now we're going to talk about something called the midpoint formula. And we are going to find the midpoint between 2 points. Okay, and in order to do this, this formula looks kind of complicated, but it really isn't. It's basically just the average of the x's and the average of the y's. Okay, so we add the two x coordinates together and divide by 2. Since there are 2, that's the average. And then we add the two y coordinates together and divide by 2. All right, so we're just going to do an example. Okay, let's say we're going to find the midpoint between points 3, -6, and 5, -2. All right, so then all we have to do is we need to add the two x coordinates. So this is like x1, y1, and this is x2, y2. Okay, so I'm going to add the two x coordinates together. So I'm going to go 3 plus 5 divided by 2. That's my x coordinate. And then for my y coordinate, I'm going to add the two y coordinates together and divide by 2. So -6 plus -2 divided by 2. All right, so then I have 3 plus 5, which is 8, divided by 2, or 4, and -6 plus -2, which is -8, divided by 2, which is -4. So my ordered pair of the midpoint between these 2 points, 3, -6, and 5, -2, is 4, -4. And it's always good to check to make sure that your answer is reasonable. Okay, so here are my 2 points, 3, -6, and 5, -2. And the answer that I got was 4, -4. And it does look to me like that is the midpoint. So the answer was reasonable. And what if we know an endpoint and a midpoint? So, like, I know that the endpoint is -6, 3, and my midpoint right here, this is my midpoint. Okay, so that means that I'm going to have to find a point like up here somewhere. How do I do that? Okay, well, there are a couple different ways that we can do this, and I'll show you both of those ways. You can decide which way you prefer. Okay, so I can use this formula, x1 plus x2 divided by 2, okay, equals the midpoint. So then I would have to go with each one. So for the x coordinate, I'm going to go -6, that's my endpoint, plus we don't know what the other endpoint is, so plus x divided by 2 is equal to that -2. And that would be our x coordinate. Okay, and I'm going to do the same thing with the y. 3 plus something, I'm going to call this one y, divided by 2 is equal to that midpoint, which is 7. Okay, and then I'm just going to solve both of those. So I'm dividing by 2, so I'm going to multiply both sides by 2. So -6 plus x is equal to -4. Add my 6 over, I get x equals 2. Okay, so the x coordinate of my endpoint is 2. Here, I am going to multiply both sides by 2 also. Okay, so my 2's cancel out, just like they did here. I just forgot to write it down. So 3 plus y is equal to 14. I'm going to subtract 3, and my y coordinate is 11. Okay, so my midpoint is, or sorry, my other endpoint is 2, 11. That's my other endpoint. So let's just see here if that is reasonable. I'm trying. Okay. So we're gonna go 2, 11, which would be like up here somewhere. There we go. There. Okay, so that is my other endpoint, and that does look reasonable. But that's kind of a lot of work. So I'm going to show you an easier way. Okay, so this is the midpoint, and we want to find whatever this x is and whatever this y is. Okay, so I'm just going to look and see. Okay, so from -6 to -2, what do we do? Yeah, we add 4. So I'm going to add 4 to -2, and what do I get? 2. Good. All right, now I'm going to go from 3 to 7. What do I do? Yep, I add 4 there as well. It won't always work out like that. And so I'm going to add 4 here. 7 plus 4 is 11. Isn't that what we came up with? So if you prefer this much quicker method, you are welcome to use this method. Finally, we're going to talk about the distance formula. Okay, the distance formula allows us to find the distance or the length between 2 points. Okay, and this is the distance formula. It looks complicated maybe, but it's not too bad. Okay, we have 2 points, and we're just going to plug them into this formula. Okay, and then I'm going to show you one more way. Okay, we're going to find the distance between these 2 points. Okay, and these 2 points are 1, 2, and 4, 6. Okay, and so I'm just going to use those points as this is my x1, y1, x2, y2. Okay, and I'll just plug those right into that formula. Okay, so the square root of x2 minus x1, so 4 minus 1. And it doesn't matter which one you call point 1 and which one you call point 2. You'll get the same answer in the end, so it doesn't really matter which one you call point 1 or point 2. Okay, so x2 minus x1 squared plus y2 minus y1 squared. All right, so 4 minus 1, 3 squared is 9, and 6 minus 2, 4 squared is 16. Okay, we take the square root of 9 plus 16, or the square root of 25, and that's 5. Okay, so that means that the distance between those 2 points, these 2 points up here, is 5. Okay, and I'm going to show you one more way to do this. So what we're going to do is we're going to use the Pythagorean theorem, and it actually works the same way. Okay, so what I'm going to do is make a right triangle. Okay, and in order to find the distance between those 2 points, we're going to find the length of that hypotenuse. Okay, so this is just another way to do it. All right, so we are going to find the length of that hypotenuse. We're going to find the length of this side, and there are 3 units here, so that's 3 here. This is 4 units long, so we use 4. Okay, and the Pythagorean theorem you learned last year is a squared plus b squared equals c squared, right? A squared plus b squared equals c squared. Okay, and a and b, those are the legs, and the c is the hypotenuse. So I'm going to go 3 squared plus 4 squared equals c squared, or 9 plus 16 equals c squared, or 25 equals c squared. Okay, and to undo squaring something, we're going to take the square root. Square root of c squared is c, square root of 25 is 5. Okay, so we figured out that C is 5 both of those ways. Okay, and usually you can use either method. Okay, so again, if that's a shortcut for you, go ahead and use it.
And someone literally just today gave me this shirt. Okay, so I'm almost back home. Let's see. Yep, so thanks for coming on this run with me. It was a great way to get energized in the morning, and I think I'm ready. I'm ready to start this year. So, see you later.